in this video I'm going to talk about what we mean by relative atomic mass. I'm going to use the chem sheets, size sheets, worksheet that you've been given to help me with it, and I'm going to walk you through some stuff that you've done in the atomic structure topic, but it's worth remembering before we do the moles topic. So shortly I'll give you a definition of relative atomic mass, which is written up here anyway. But before I do, I'm just going to remind you the definition of isotopes before we get going. Okay, so isotopes, when we've got atoms of the same element, which have the same number of protons, which is why it's the same element. Number of protons, by the way, is the atomic number, the small number that you get on the periodic table. And there's different numbers of neutrons. We'll work out the neutrons, remember, from the mass number, take away the atomic number. Okay? So, for example, chlorine has two isotopes. They're naturally occurring in significant quantities. There's chlorine 35 and chlorine 37. And 75% of all chlorine is this one, 25% is the other one. The atomic number for both of them is 17, because it's got 17 protons. This one's got 18 neutrons, which is 35 take 17. This one's got 20 neutrons. Okay. Now, you will need to be able to give a definition of relative atomic mass, which is the average mass of all of the isotopes of an element. That's worth 1 mark. Average mass of all isotopes of an element. But you want to add, really taking into account the percentage abundance, which we'll do in the calculation in a second. But the key thing for the second mark is to say that it's all relative to 1/12 of a carbon atom. A carbon 12 atom. This is all because when we're using numbers for mass for atoms are so tiny that we can't use a mass in grams realistically and sensibly. So it's decided that the relative mass 1 is defined as 1/12 of the mass of a carbon 12 atom, which has got 6 protons and 6 neutrons. 1/12 of that is 1, and everything else is compared relative to that. That's what we mean by relative atomic mass. So to do the calculation for relative atomic mass, we have a look at the percentage abundance of one isotope and multiply it by its mass number. So the percentage abundance of the first isotope, 75, and multiply it by its mass number. And we do the same thing to the other isotope, 25% times 37. We divide all of that by 100. This looks familiar to you from maths. It is simply doing weighted mean or weighted average calculation. If you plug it into a calculator, it should always come halfway in between the extremes of the mass number. So it should be somewhere between 35 and 37, closer to 35 because the abundance of chlorine 35 is larger. And if you pop that into a calculator, it should come out as 35.5. Okay, 35.5, and that's what you'll see on the periodic table. I'm going to show you the worksheet you were given in class, which looks like this one. I don't much like the description at the top about the ball, so I'm just going to ignore that. There's a nice worked example done for you here, and I've worked out a second one for you here. So the lithium one, the mass number times the abundance. So the mass number 7 times the abundance. Add to the other one, percentage abundance is 7.6 times the mass number there. Add those two numbers together, then divide by 100. It should come partway between 6 and 7, partway between the two extremes, and it does. It comes to 6.92. If you've only got one isotope, the relative atomic mass will be the same as that single isotope. And that, folks, is how you do relative atomic mass calculations. Cheers.